my name is Jami Emigh, and I'm here today to give you a lesson on finding the volume of a pyramid. So I'm going to start by helping you derive the formula. First of all, let's look over what a pyramid is. We're going to be looking at this type of pyramid. The base of this pyramid is actually a circle. So this is a special type of pyramid. It has a special name. It's called a cone. And we're going to relate the formula to this special kind of prism. This particular prism has that same special base of a circle. So this particular prism is called a cylinder. Okay? Notice that the cylinder and the cone have the same bases. So we're going to use our past lesson on the cylinder to help us with our lesson on the cone. Okay. First of all, a cone is three-dimensional, so we call it a polyhedron. So to draw your polyhedron, what you want to do is take your base, which in our case is a circle, but don't draw a circle. You want to squish your circle. So it's going to look like an oval. Okay. And now to make this effect of all infinitely many point lines, segments going up and meeting at one point, instead of us going like this infinitely many times, we can do this if we want to. And that'll give us the effect of the cone. You see that? There are infinitely many lines because there are infinitely many points on the circle. But we don't have to do quite that much to help us find information on our cone. We're just going to draw two lines, and those are going to represent the entire surface area of the cone. Okay, so for the formula of the cone, well, if you guys recall, the formula for the cylinder was volume equals, that's capital B, remember that's the area of the base, times the height. Remember that's this height here. And for our cone, it's very similar. But if you look at the two shapes, there's no way they're going to have the exact same formula. This one's quite a bit smaller. So we're either going to be subtracting something off or dividing, somehow making our volume a smaller amount, because it's not a cylinder, it's a cone. In fact, if it turns out that this is exactly 1/3 the volume of this one. So to find the volume, all we have to do is divide it by 3. Do you believe me? You shouldn't believe everything you hear, right? You should always try to question it. So first, just think reasonably. Could this possibly be 1/3 of this? Could this be 3 times as large? Well, it seems reasonable. I may have guessed closer to half the size. Some of you may have guessed closer to 1/4 of the size or somewhere in between. So reasonably, it's possible, right? If you have the means to actually test a formula that somebody gives you, you should. So I have a cone and a cylinder, which have the exact same area of the bases. And we claim that it's 1/3 the volume. So we're going to find out. I'm going to see if, remember this is three-dimensional, so I have to use water. I'm going to see if this cone will in fact fill this exact cylinder. This cylinder, which has the same base area and the same height, that's key. And it should be exactly 3 times. Twice. It's looking pretty good. One more. Let's see. Whoa, it's going to be close. Wow. And almost exactly, it's bubbling over. I don't know if you guys can see, but it does fill the cylinder with the same base and same height exactly 3 times. So we can thank whatever mathematician figured that out for us, because we just get to use their nice formula of base times height divided by 3. Okay. Recall that the area of the base is going to be this 2-dimensional surface area, which happens to be a circle. So that area right there is going to be, anybody remember the area of a circle? The formula for the area of a circle? It is pi r squared, if you can't remember. And then our height is going to be the altitude. So we need to go to the tallest point there. That comes down to a perpendicular line, meeting our base at a 90-degree angle. So this is going to be our lowercase h, our height. We know our r is this right here. It's looking a little cluttered, but hopefully that'll help you. So let's go ahead and try it, okay? So So on this one here, so your teacher gives you this problem, right? And it says, find the volume of the pyramid. This is a special type of pyramid. Do you guys remember what it was called? A cone. Very good. So ours is a special pyramid. It's a cone. And to find the volume of a cone, hopefully what your mind should do is go, okay, volume of a cone, that's very similar to a cylinder. I know that that formula was the base. So right there I'm going to have to put the base, the area of it. Then I'm going to have to multiply that by the height, and then I'm going to have to divide by 3. Okay? I like to set it up like this. So it gives me a blank template. So now I have direction. I fill in that blank, I fill in that blank, I calculate, and I'll have the volume of this cone. Okay, so let's see if we can fill in those 2 blanks. Okay, so that first blank stands for capital B, which is area of this circle right here. So the area of that circle, capital B, is pi times the radius, which happens to be 3, squared. So that capital B for this cone is 9 pi square inches. Okay, so we're going to plug that into our first blank. So capital B is 9 pi square inches. 1 blank down, doing good so far. Our second blank, you might have to look back, it is the height. So I'm looking over here at this cone trying to find the height, right? Unfortunately, they didn't give me this height right here. That's what I need. They gave me this height, the 5. This is called the slant height. Oftentimes it's used, represented by the letter L. Don't get the slant height mixed up with the regular height, okay? We need to find the regular height. Now, some people might stop right here, but you can't just stop. You have to go hunting for information if they don't give it to you. So when I look at this, and I know what I'm trying to look for is this H right here. I spot something very special. Do you guys see it? Good, a right triangle. And not only is it a right triangle, it's one of Pythagoras' special right triangles, which dimensions are 3, another leg of 4, and a hypotenuse of 5. So I know that H right there is 4 inches. Now if you haven't memorized Pythagorean's triples, you can just step off to the side over here, and you can do Pythagoras' theorem, which is 3 squared plus your H squared equals your 5 squared. Do your arithmetic, careful of your order of operations. Subtracting 9 from both sides. I'm just trying to solve for H, that's my goal. 25 minus 9 is 16. I have to square root both sides, so I get my H out of 4. So if you didn't have the 3, 4, 5 Pythagoras triple memorized, that's okay. Just solve it right here using Pythagoras' theorem, okay? So we do have our H. We found it. It is 4. So I can go ahead and write in my second blank that that is 4 inches. So I've plugged in my entire formula. No more blanks are left, no more variables. I can now just do the arithmetic, and I have the volume of my cone. So here we go. Volume equals, so I've got 3 pi and a 4 on top. That's all multiplication. I'm sorry, 9 pi rather. So 9 times pi times 4, that's going to give me 36 pi. And I've got inches squared and an inches to the first power, so that gives me inches cubed. And I have to divide this by 3, right? If I was looking for the cylinder represented by this base and height, I would be done. But since I have just the cone, I need to divide by 3. So I just reduce here. 36 divided by 3 is 12. I'm going to go ahead and leave this in terms of pi, unless my teacher or my assessment specifies otherwise. And then my inches cubed is already calculated for me. I'm going to box that answer, and you're done. So my name is Jami Emigh, here to remind you that the numbers never lie.